Hello, my name is Scott Brown, your host at Green Wind and Other Home Energies. This is the second program that I really wanted you to look at, and this has a lot of pertinent information. This is the wind turbine calculator. This is a program that will calculate electrical output of a wind turbine in watts and horsepower from the blade rotor size and the speed of the wind, and calculates a few of the measurements conversions just to help out. Please use capital letters, blah blah blah. M for metric and S for standard. I'm in America, I'm hitting standard. Don't worry, you'll have all the metric measurements. 7.5 feet. And leftover inches. You entered 7.5 feet, which is 7 foot 6 inches. It doesn't matter how I entered in. I've already programmed it. We'll take care of it. Yes, okay, this is correct. Now I need the wind speed. Let's say, let's go with a 20 mile an hour wind. Alright, is this correct? Yes. And elevation in feet, I'm just going to go at the 1.23. Okie dokie, anytime when ready. Overall efficiency of the machines, 0.35. Air density is 1.23. Diameter of the rotor, 7.5 feet. And 2.286 meters. Alright, the diameter of the prop in inches, 90 inches. Windswept area in meters, 4.104, and windswept area in standard, 44.17 square feet. Alright, wind velocity standard, 20 miles an hour, that's 8.9408 meters per second. Power out in watts, we're looking at 631 watts, that's 0.846 horsepower, and sure, yeah, we'll calculate another one. And yep, we got enough memory on here to do this again. Let's do it in standard. Well, let's show you something. When you double the, let's see, 7.5, yes. Alright, 7.5 feet again, and we're going to go with 40 miles per hour, just for giggles. Is this correct? Yes. Elevation in feet, of course. Pang, pang. There we go. Now I want you to look down here. It's 5,051 watts. And that's 6.77. We only doubled the wind. That's the only thing we doubled. Now here's what I've got to explain. When you double the size of your prop, you go up by a factor of 4. That's 4 times. But when you double the wind, you go up by a factor of 8. If you doubled your prop and you doubled your wind speed, you go up by a factor of 32 times. So, when somebody says they've got a 1.5 kilowatt wind turbine, well, maybe the wires can handle it, but does it take a 36 mile an hour wind to get it there? And if you if the wind goes down by half, you've only got 1/8 the power. How many days of the year do you have 35 mile an hour winds? And if you go down to our normal winds, well, we've cut it down by another 1/8. So that'd be 1/64 of the power. I'd say building your own is the best way. I'm Scott Brown with Green Wind and Other Home Energies. Okay, one more quick point. This is 7.5 feet. If I divide that by 2, that's 3.25 feet. And everything down here would have to be divided by 4 because your factor is 4. If I doubled this, I'd have to multiply everything down here by 4. The same thing with the wind, except it's by 8. If I went half of this, everything down here is divided by 8. And if I decided to double this, everything here would be multiplied by 8, including your horsepower. And you can figure a lot of different things about what you're ready for using that. And if I showed you a 5-foot prop and a 10-foot prop and a 10 and 20 mile an hour wind, you'd have the rest. Alright, I want you to get a good shot of this screen here. This explains a little bit, and actually it's the formula with the explanation for each of the terms. Next I'm going to show you all the okay, this is for 5 miles per hour with a 5-foot prop. This is basic, and you can double the prop size and you can double the wind size and go up 32 times. I'm giving you this just so you can make calculations. I'll do the next one and show that as well, and give you a basis where you can make a full chart just by multiplying and dividing without having to go through all that fancy calculations and stuff. Alright, here's 10 miles per hour with a 10-foot prop. Alright, here's a 15-foot prop and 10-mile-an-hour wind. And a 15-foot prop and a 15-mile-an-hour wind. Okay, this is a 10-foot prop and a 30-mile-an-hour wind. Nice numbers down at the bottom. The wind is the main factor, but you're always going to get these results. Well, you should get these results. These are optimum results, the power available in the wind per size of prop. You can only get these out if your prop is matched to your alternator. If your prop is not matched to your alternator, it's too big, it's going to turn too slow, and you're not going to get the voltage until the wind gets up there. And then when it gets up there, you're not that much higher than your battery voltage, so therefore you're not trickling any amps into it hardly. If your prop is too small, then when it starts when the amps get drawn on it, it's going to slow down and stall. So sometimes if your prop is a little small, you can add some more wire or add more batteries in line, and basically adjusting your voltage to your batteries is a pretty good way of doing things. A 48-volt system, if your prop is too big, then turn it into a 24-volt system. Anyway, these are some nice readings for you to figure out your expected power in watts. If you're running the same amps and twice the voltage, then you've got twice the power. So figure all of that out, and hope these numbers help you out to figure a lot of things, and you don't have to buy a program off of somebody, and you don't have to go through all the figuring yourself. If you can flash on this video and put your mouse, put it on pause on something that you can multiply or divide, you got it made. You take care, and many good things to you and yours. I'm Scott Brown with Green Wind and Other Home Energies.